So we are back yet with our lesson 3 of trigonometry, and we are going to begin with compound angles. We are going to derive them from first principles and see how best they can be applied. Concerning application, I briefed you in lesson 2, so you know what application means. So we are going to straight away begin with compound angles, see how we can memorize on top of us having them available in our logbooks. Yes, so we are going to begin compound angles, or we can say compound angle formulae like that. Compound angle yeah, like that. Okay, now compound angle formula is going to be divided into a lot of things, but we are going to follow the very order that we have in our logbooks. So I want to first give a direction or a reference in the logbooks, so that at least people take it serious to have a logbook if they really want to pass this subject. So reference. So I want you to tell me the page. Yeah, the page you have in that current logbook. So you all know trigonometry, formula 12. So where do you have formula 12? Is it on page 60? Which page in the logbook? Is it page 60? I want to confirm with you people. Yes, I think I'm seeing some people saying page 60. Let me hope it's the right one. Okay, page 60. So I'm going to come here and give you the reference as the logbook. You know, some people have old editions. Which editions do you have when you check the cover page? Which edition do you have? Third edition with 4-figure tables. And we have agreed. It's in the logbook and it is formula 12, formula 26. So we are going to be following that very order. So according to the logbook that you have the third edition 4-figure tables, you can see the very first one was the first trigger identity, then 13, second trigger identity, then the third was the third trigger identity. And those ones were covered. So I'll tick them again. So I'm going to remove all these ticks and then tick slowly. So concerning the first trigger identity, we got done. Second, we got done. This we got done. So we are beginning with this, that very order is the order we are going to follow. Yes. Up to 21, then we first put a stop and then we start doing numbers like that. We see if time can allow, then we go into factor formula like that. Okay, so according to our logbook, we're going to begin with let me first secure our document. So this is trig 3, yeah. So we are going to begin with the standards, the ones that give us the others. Okay, now we are going to begin with sine in brackets a plus b like that. Then the next one is sine a but with a minus. I want you to follow. Then the next is cos plus and this one like that equals. So these ones, they have derivations, but you don't need the derivations at your level. Let me tell you this, anything they provide in the logbook, they don't need you to learn how it's derived, especially for pure math. So for the standards, these ones, just understood, not derived, no need to know how they come about. But of course, how they come about, the way it is it. That now will be your personal research work, but you don't need it. You just need to understand how they are, period. Now, I want you to listen. I want you to listen very well. So that's what we have. We are having sine and sine, cos and cos. There is when the angles are added, there is when the angles are subtracted. Let me hope you know that A and B are angles. We have been doing that ever since lesson 1. When I say sine 30, the 30 is an angle, isn't it? So this is it. When you're having, let me begin with sine. When you're having sine, you will have sine and cos. Even this side, you're going to have sine and cos. First listen, if you're having sine, and in brackets you're having our angles, either added or subtracted. What have I said? We shall always have sine and cos. What have I said? We shall always have sine and cos. Yes, these things are there in the logbook, but it's not that every time you'll be copying in the logbook. You should find a way of how you can memorize them by heart. And it's what I'm trying to do right now. And then, if you're having cos, you'll be having cos and cos. So because you're already having cos and cos, that means you're left with no option other than having sine and sine this side. Sine, then sine. You get? What have I said? When you're having cos, whether the angle is added or subtracted, what are you supposed to have? Cos and cos. Then this side you will have sine and sine. I don't know if we are together there. Who can raise up their hand and tell me what I've said? I want very fast. You hurry. What have I said when you're having sine? What have I said when you're having cos? Yes, Fad. No, danger. Yes, danger.
You've said
Mm-hmm.
when you're having sine, you write
Mm-hmm.
sine, cos, and then
Even the
sine
other
and cos
side.
the other. Sine
No,
and
good.
cos.
Mm-hmm.
Then
Then
if
for
you're
cos,
having, we write cos and cos. Then the other side we write sine and sine.
that is good. That means that person is following. Now we can proceed. Now after that, we start distributing angles. Yes, we start distributing angles. How? How? So, the angles are only 2A and B. That means if here sine takes A, cos will be left with no option other than taking B. You understand? Then this side, since sine has already taken A, it will now take what? B. Then since cos took B first, it will now take A. You understand? Even here the same thing. Sine can decide to take A first, then like that. Then the other side, sine can now take B, then cos can take now A, like that. Then here where you're having cos A and B, here you have no option. If it is cos and cos, so they decide. They be like the first cos, okay, take the A, then the other cos, let it take the B. And it is just cos. So one takes A, the other B. Then the other side, Sine takes the A, then sine takes B. Same thing here. AB, even here, AB. I want danger again. Where are you? Danger, unmute. Where is danger? Now I want you to tell me. You talked of this is what you told us. You told us that for sine we write sine cos, then even here we write sine cos, isn't it?
Yes.
Then you said for cos we say cos cos, then this side we say sine sine, not so?
Yes.
So assume my angles are Q and R. Tell me what I
Mm.
should put here and also here.
On this first sign, put Q.
Mm-hmm.
Then the cos, put R.
Mm-hmm.
Since this first sign has taken Q, the second sign is going to take R.
Mm-hmm.
And then the cos will take Q.
Very good. Then
Now this
cos.
first cos is going to take Q, the first one.
Mm-hmm.
And then the second one take R.
Mm-hmm.
So there is no option for this one. They'll also take Q and R.
Yes, you are following. Let me hope you're not going to doze around 3 a.m. Will you be sober around 3 a.m.? Okay, that is good. That is good. So when you understand that, the remaining part of the signs is not actually very hard. Is not hard. So danger, prepare to unmute again and finalize what you started. Yes. So this is it. Now, for sine, we shall maintain our sign. Yes. For sine, we shall maintain our sign. Nothing will change. So, if before the angles were added, even here we shall add those two. If here the angles were subtracted, even here we shall subtract the two. But for cos, the opposite will happen. Just like the way I taught in differentiation, that when you're to differentiate sine, it will give you cos. Positive cos without changing a sign. But when you come to differentiate cos, it will give you a negative sign. So that's what cos usually does. It's just there to confuse up, to mix up things. So even here, when the angles are added, cos says no. For me, I'm going to subtract here, the two. When the angles are subtracted, cos will say no. For these ones, for me, I'll just add them. So for sine, we maintain them. But for cos, it says no. I will not allow that. Danger, unmute and finalize this. Where are you? Raise up your hand. So you listen to the instructions as you unmute. So danger. We have something here and something here for that first one. Even for the second one, we have something here and there. You're going to just tell me the signs that are going to be in between because it is very important. The first one, what should I put with the reason?
You're going to put a plus because for sine, the operation does not change.
Mhm.
For the second one, we are going to put a minus because for cos, it changes the sign. Then for the third one, we are going to put a minus because the sign does not change for the sign. So for the fourth one, we are going to put a plus because the cos changes the operation sign.
Very good. Very good. I think people are now getting it. So that's very important. So even when you have these things in the logbook, you should find ways. You should find ways of making sure that there is a way you can recall them in your own local way. Yeah. Otherwise, now I can show you what the logbook has because it may need some little interpretation, maybe. Let me first save this document. So actually we are done. If you get those two, we are done. If those two have been very clear, just know we are done and you're going to understand the rest of the things. Because what I've just explained is the hardest in this session. So if I told you you've not found hard time with it, we are done. Because remember, tan is sine over cos. So when you know the sine and cos, then you know tan by default. Yeah. Okay. Now, hope we are together. So when you come to the logbook, you will see what these people will do, and you're supposed to interpret it very well. So you can see that for sine, I think you can see the sine A cos B, cos A sine B, whatever. Then even here you can see cos, whatever. So what I want you to see is this. For sine, plus, minus, even here it was maintained as plus, minus. But for cos, here it was plus, minus, but here they said minus, plus. Trying to show you plus goes with minus and minus goes with plus. Cos, it is cos, then the other side, sine. But for sine, it is sine, cos. Then the angles exchanged. Simple as that. So let's see, how does this one come about? The tan A plus B. Yeah, maybe. Okay. The tan A plus B is also somewhat weird, but we are going to handle. So we should actually even give it the heading expression. Okay, so we go. So you all know that tan alone is sine over cos of that same angle. So we are maintaining the angle. I don't know whether that step is okay, and it should be okay with you. It should be okay with you. Sine A plus B is equal to cos A. Sine A plus B is over cos A plus B. It should be okay. Maintain the angle, then where you have tan, you put sine over cos. Hope we are together. People, is that step okay? In case it's not okay, you raise up your hand, yeah? But just like the way you say that tan theta is sine theta over cos theta, eh? So we are also removing theta and putting A plus B, A plus B, A plus B. Yes, Fad.
So it's a must to do like that.
But we have not yet started doing any number.
Okay.
You first learn the expression, then you wait for how numbers are done. Then maybe you can ask what you exactly want to ask from there.
Okay, thank you.
So the one on top will be sine A, then cos B from danger. Then you shall have sine B, cos A. Yeah. Then out of this side we'll have cos A, cos B. Never forget the minus. Then here you have sine A, sine B. Now, let me tell you, all students reach that step, but leaving that step is what gives students hard time. Trust me, all students leave that step, reach that step, but going to the next step is the hardest thing ever. Students are not always sure what exactly they should do when they reach that point. Yeah. And I want to just make you remember only and only one thing. Are you seeing this kawan here? I don't know if you can see it. Are you seeing this kawan? It's the only thing I want you to remember. That every time they give you anything in tan, even if it is tan maybe AB plus XY, any tan, for just recall one thing, that there is a division sign, and here at the beginning there is a 1. Don't even mind about this sign, because that sign changes. For just recall only and only this 1. Only that one, nothing else. Only that one. So just remember that there is a kawan there. When you remember that there is a kawan there, things are going to become very easy. But if you don't recall that it is there, then problems. But if you recall, then you'll be very safe. So people can see that. So I'm going to pose a question for you people. Right now, we know that we are supposed to have 1 in this position. Isn't it? How can you make that one a 1? Who can raise up their hand and tell us? Because we want to make it a 1. We want to make it a 1 because it's what we have. How can you? It's like asking you, how can you convert a 2 into a 1? How can you convert a 5 into a 1? How can you convert a 10 into a 1? How can you convert x into a 1? You get? In a way that is not going to disturb. Yes, Eric.
Good evening, doctor and other people. Yeah, for me, I think the only way we can make it a 1 is by dividing through by that very cos A cos B.
Thank you so much. That is it. So the easiest way, but of course not the only way, but the easiest is simply saying over 2 you get a 1, over 5 you get a 1, over 10 you get a 1, over x you get a 1. So anything, provided you want to give it, you want to turn it into a 1, divide it by itself. You understand? Yeah. And then you will get the one you want. But to make sure that you've not made a lot of changes, because you cannot just out of the blue just divide by 1 like that. Sorry, by itself. To make sure that what you've done is fair, you divide by cos A, cos B throughout the whole thing. Because when you just do it on one thing, that is not being fair. You're supposed to now divide throughout. So you're supposed to come here and say divide or dividing throughout. Dividing throughout by that very thing. The cos A cos B, so that you create there a 1. And when you create there a 1, that means you're good to go. Yes. So I'll come and say here, what do I have? I had my cos A, sorry, sine A cos B. So I divide by what? I've said throughout we are dividing by cos A cos B. Then plus, what did I have? I come back. I had sine B cos A. So I come and write sine B cos A. What am I dividing it by? I said throughout, so whatever is there, I'm supposed to divide it by that thing. Then I bring my long division sign, the long one. Then I also finally reach my place where we are supposed to introduce a 1. And of course, what is there is the same. Cos A cos B, and I'm dividing it by the same thing. So the 1 is already created. If you recall, that was a minus, and the other one was sin A sin B. If you can confirm. This is sin A sin B. Now, I come here, I have my sin A sin B out of. So most of you have a tendency of cancelling your work. Those things are not allowed in math. You just cancel from your brain. Some of you like doing this. You say like, this is cos B, cos B. Come and say this is cos A, cos A. Say cos A, cos A, cos B, cos B. Those things are very bad. If these things cancelling, just take it. Like, be like, oh, they have cancelled, period. But some of you overdo it unnecessarily. This one is out. Okay, so I don't know. I want you people to look at those two steps and tell me if we are at the same page. You look at them. Are we at the same page? Should we now begin the cancelling? Because we are done. We are done. We are done. Okay. So I think we are the same page as people have said. So realize the very first thing, cos B will cancel with cos B, and you remain with, I want you to follow here. For me, I'm going to cancel, but later I'm going to rub. So cos B is cancelling with cos B, and I'm remaining with sin A over cos A, which is going to give me tan A. So I'll write tan A. You get? So remember what I have here is my tan A plus B, like that. So this side, I've said sin A over cos A is what is remaining, which is tan A. Plus this side, I can see cos A is cancelling with cos, and I'm remaining with sin B over cos B, which is tan B. Out of cos A is cancelling with cos A, cos B with cos B. So I'm having a 1 here, then minus. Here I have nothing that is cancelling, but all I know, that one is tan A. And then the balance is tan B. And then I'm done. Like that. Then I can cancel like that, like that, like that, like that, like that. Like that, like that. Now I can make my work neat. Yeah. So I cancel, use the expression, and then dump it. And then come up with my clean expression like this. So I'm not going to waste time to also do that of tan A minus. But we are going to just do some comparison together. You people can see that for tan, something serious comes up. Let me teach you the technique so that you also learn it. So this is what you do for tan. That has been the proof, but this is what you do for tan. So if you're having your tan, and this is a B like that. So have it in mind that here you will have the tan. Even here you'll have the tan. And also here you'll have the 1. Then here you'll have the tan. And that one never changes. It is always like that. Tan, any angles, whether added or subtracted. On top you have tan and tan. Then down you have 1 dash tan and tan. You get? So this is what we always do. Of course, if the angles it's A and B, so we have here A, then here B, we have no option. Even here we have our A, even here we have our B, like that. That's how it's always. But then from what we have just derived, you can see that this was a plus. So we maintained and then what? Changed. Do you see that? We maintained and then what? Changed. So if this is a minus, I've said in the numerator we maintain, but in the denominator we do what? We change. I don't know if you people are getting. Do you see that? That for tan, I've said tan and tan on top. Then down we have one, then the other side tan, tan. On top we shall maintain the sign. Then as we go down, we do what? We change. Period. That's what we do. Who has gotten it? Raise up your hand. I put your questions here. Anyone who has gotten what I've said? Anyone who has gotten what I've said? Raise up your hand. I test you. I think David Cabio, you have never said anything. Unmute. Then I think, who else? Who else? Janat, get ready for the second. You tell us.
Good evening, members.
Am I also
Attending
part
this,
of the members? Am I also part of the members?
no, I'm first greeting the audience.
Oh, so the
Good evening.
audience is more important than me.
No. Good evening, doctors.
Mm.
Pertaining this one, we said tan in the bracket r plus xy, the expression will be like this. Since the tan is in positive, actually, since r plus b plus x, y,
Those are the
that one,
angles. So since the angles are added.
since
So
angle,
you first do the other thing we said, that on top we shall have tan and tan, isn't it? Then down we shall have here, we must have a 1, then here we shall have tan, tan, isn't it?
yes.
So I want you to tell me what to put here, which sign to put here,
And
what
in
to
the,
put here, what to put here, what to put here, and what to put there.
in the first time which is up, we are going to put arrow, and then the sign will be negative.
The sign will be what?
This sign will be negative.
Here we should put a negative.
Yeah.
You're lying.
Okay.
Remember tan is sine over cos, not so? So you said how you can recall this. With sine we maintain, so even for tan on top you maintain the sign. Then for cos, since we change, even in the denominator of tan, you change the sign. Do you understand?
Yeah.
So that one is supposed to be a plus. On top you maintain. Have you had?
Understood. Yeah.
Yes. Then here, what is the angle?
Angle here will be x, y.
Is our xy. Yes. Very clear. Then here it will be 1 what?
1 minus tan arrow.
Exactly. It will be 1 minus tan r.
And then tan x, y.
Tan xy. Thank you so much. Janat, where are you? So I'm putting the xy. It shouldn't confuse you. The xy is nothing. It's just like any other thing. So I think now people know the trick of xy. So I think I can now put here something obvious, maybe p. minus Q. Yeah. Where is Janat? Yes, Janat. Blessed daughter, get ready for the next question I'm asking.
Yeah.
What should I write?
You're going to say tan P,
So I first
tan
put here
P,
tan, even here tan, not so?
yes. Then
Then I
even
put here
down,
1,
1, then tan.
tan. So we are filling these spaces in that order. So you just tell me what I should put in that order. So we are beginning from here.
Here we're putting tan P
Tan P,
minus
minus
tan Q.
tan Q,
Then you are putting 1 plus
1 plus,
tan P tan Q.
tan Q. Thank you so much. That is
You're
it.
welcome.
That is it. So you people, before these things are there in the logbooks, but before you even be like, they're in the logbook, I'll just copy. First, try to find out how you can recall them as a person. Because the more you get them from the head, the more they become easy for you. So you can also find it easy, to deal with them. You don't get disturbed at all. Okay. Now, that is it. So when I come here, I think you can see people. You can see. So one thing you can use to recall is that tan is sine over cos. Sine is the numerator, so we maintain the signs in between. That's why you can see plus minus even here, plus minus. But since tan is sine over cos and cos is down, and cos deals with change of sign, that's why you also see that down we have minus plus, meaning we have to change signs. But shouldn't forget it is tan, then 1, then tan. Something like that. We just need to repeat them the way we've been doing them and you'll be good to go. Yeah. So we are going to see the special cases, what they call special cases of the compound angles. So before I take you to this, remember for today, we are going to first go up to this point and see what we really need to do. Remember, I secured my future as far as finding angles is concerned. So don't expect me to get any angle in this lesson. There are only a few angles I'm going to get for you. A few, but it will be you people getting them. Yeah? There is a certain case we forgot, but it's better here when people realize how compound angles look like. So we shall end somewhere there and we see. So I think it's a good move. Kali, where are we? So we now proceed. What do I want to bring next? They are what we call the special cases. These special cases are the ones that make you a real student. I want someone who has understood the things we have on top. You unmute. You all know I first ask you to unmute before I bring my questions. So who are those strong people? Rebecca, the one who disturbs me the most. So Rebecca, you're going to tell us. You're going
Yes.
to do this. Are you ready?
Yes.
Yes, Rebecca. One day Rebecca told me that She told some of her friends to come and study, and they told her that I'm going to give you poison. So I don't know if I've ever given you guys poison. I don't know, but I don't usually do that. So let's assume that A is 90. That's what we are assuming. So Rebecca, you're going to tell us. So we are removing A and we are putting 90. So be ready. Do you have a calculator?
Yes.
That is good. So now we begin. You expand for us the first one.
So the first one, it's sine 90 degrees,
Sine 90.
sine B,
First, wait, before we even go any further. It is sine. Then what should I put here? Before even fill in the angles, what is it? Is it sine, cos, or
it is sine,
sure?
sine cos,
Sine, cos. Then there is a sine here. Then this side, we also have sine, cos again. It is better I always do this. This will hope you recall, but if at all you want to do it manually from the beginning to the end, it may disturb a bit. So for sine, the same thing, we say sine dash cos. Then here, same thing, sine, then cos. Then for cos, what did we say?
we said for cos 90 degrees plus B, it's going to be cos,
Cos. So at least you first recall this, that it is cos. Then a sine here, then this side, you can have the sine. Even this side, even this last one, cos and cos. Then you can have a plus. Then this side, you have sine and sine. That is very important. Now let's fill in the angles in this order, in that direction. Yeah? We begin.
So for the first one, it's going to be sine 90,
Sine
cos,
90. Cos B.
then that will be plus
Plus.
sine B, cos 90.
Cos 90. Very good. Very good. Then the next, same thing, not so?
Yes.
Same angles, but since here we are having minus, and for sine we maintain even this one will be minus. Then for cos,
For cos, we shall have cos 90 degrees, cos B. Now here the sign is going to change. Cos
to
changes.
minus.
Yes.
Now for you understood. You understood and you are very safe.
And the negative sign will become a plus sign.
Exactly. Yeah, thank you so much. Now get your calculator. Do you have your calculator ready?
Yes.
You press, what do you get when you put sine 90? sine 90. What do you get?
1.
Hope your calculator is in degrees. So sine 90, you get 1, yeah?
Yes.
Then what do you get for cos 90?
A 0.
What do you get?
A 0.
0. So you've said that sine 90, of course, degrees, you get 1. And then cos 90, we get 0. Not so?
Yes.
Are you there?
Yes. Yeah, I'm
So
there.
are you seeing that the whole of this, since this cos 90 is a 0, do you see that the whole of this is going to be affected?
Yes, Doctor, I see that.
Let me try to create some space. So this one will be sin B cos 90, because I need that space. This one is sin B. So for cos, where I had plus, this one becomes minus. Then this side is sin 90 sin B. Then yeah, I'm having plus sin 90 sin B. Let me create some space for what I want to put the other side. Okay, now you've said cos 90 is a 0, right?
Yes. Yeah.
That means the whole of this is going to be lost because this is a 0. The whole of this is going to be lost because this one is a 0. The whole of this is going to be lost because cos 90 is a 0. And the whole of this is going to be lost because cos 90 is a 0. Isn't it?
It is.
But remember, sin 90 is a 1, sin 90 is a 1, sin 90 is a 1, sin 90 is a 1. Not so?
Yes.
So do you see that the whole thing has reduced to cos B?
Yes.
Do you see that happening?
Yeah, I see it happening.
Good. This now the next one that it has also reduced to cos B.
Yes, I see that.
Do you see this last one now reducing to negative sin B?
Yes.
Do you see the last one reducing to sin B?
Yes.
You get?
Yeah.
So those are what they call the special cases. The ones they call the special cases. Yeah. So thank you for that. You can now mute. So I don't know. Do I have any questions about special cases? I want to see in the chat who has gotten confused anywhere. Oh, it's very okay. Is it okay? Someone has been cos B, cos B, cos B, cos B. People I'm asking, is that okay? I think it's okay because it has just been very okay. So I'm going to leave you with a task. You do your own special angles. You do your own special angles. Now someone may be like, now doctor, what about tan 90? Why haven't you talked about tan 90? Yeah. That one may disturb a bit because of a lot of reasons. Because when you go to your calculator and put in tan 90, it may even bring something weird. You put tan 90 because I know deep down people want us to do tan 90. But you put tan 90, you write what you're getting in the calculator. You see, they're bringing math error. They cannot bring syntax error. Yeah, when they bring syntax error, you people, syntax error and math error mean two different things. Yeah. So they cannot bring syntax error. They are supposed to bring math error. And if you did my research about the curves of tan theta, you know why it's like that. I may not over-explain that. So for tan, we are going to do 45. Yeah, and then tell you, you all know if it is tan, it'd be like that. You all know. Okay, let's put 45 at once. Let's not waste time. Tan 45 degrees plus B. So we agreed we are supposed to have, Anyway, who is ready to do that for us? Who is ready to do that for us? Who is ready to do that for us? Who is ready? You first say everything as I said it. Yes, Gladys.
Good evening, doctor.
Yes.
So it will be, the numerator will be tan
Tan.
over 1, then tan. So since tan theta it is equal to, okay, since tan theta equals to the sine theta over the cos theta, we maintain the sign on the numerator since we're using the sign. So it will be plus.
I've put it.
Then the denominator will be minus since we are having cos.
I've put it.
So it will be, on the numerator we shall have tan 45 plus tan B out of 1 minus tan 45 tan B.
When you say tan 45, 45 is in radians. How do you confirm that the 45 is in degrees? You say tan 45 what? Degrees. Have you heard?
Degree. Okay.
What is tan 45 degrees on a calculator?
Size 1.
It's 1. So you finally come and replace and be like tan 45, it is a 1. Plus this one is tan B. Out of this one is 1 minus this one is now tan B, like that. These are what they call special cases. You can't even see how it looks like. It really looks like a special case. Yeah, no error. Special case. Special case. So if at all it becomes minus, you know what to do. So I think you can see that it was plus, numerator plus, but down minus. For a reason Gladys Gift has said. That means if they wake up one day and now make it minus, you know what to do. Yeah. When they make it minus, now I can also use the knowledge of the logbook. When they make it minus, even this one will be minus, but down it will be a what? A plus. Like that. So I don't want to waste a lot of time on that. Yes. Okay, that will be enough. So I think I'm going to give you some other task, but it will be done in your free time. Yeah. Evaluate. Evaluate. I'm going to be giving you total. This one, I want you to handle 180 degrees. I'll be happy to see answers of this. Yeah, let me use cos theta. Then I use x. Yeah, these are things that will make you stronger in the topic. You'll be seeing things coming out and you'll be very happy. Then E. Okay, let's now assume that it is be that they have substituted 4, so that I can say maybe a plus 135 we'll enjoy these ones, I know. Yeah, that's enough. So when you pass those ones, I'll be very happy. Yeah, and I know you pass them. So you take a screenshot and let me tag it as assignment 1. Because I think for today we are living with a lot of assignments. Assignment 1. So you can take that screenshot and send it to the premium discussion group so that people can receive the first highlight. So we are done with the special cases. Let me hope now there is no problem at all. Yeah. The rest of the things are going to come in, the triple angles and so on. We are going to be doing the same things we have been doing. Okay, that one I'm done. So, allow me to introduce something so important, but still under compound what? Compound angles. Compound angles simply means angles that are compounded, whether adding or subtracting. So allow me to introduce the subtopic called double angles. So we are going to learn them. We are not going to cram anything. Double angles. Double angles. Yeah. So in double angles, who can tell me what is the opposite of double? You see, okay, what is the opposite of double? The opposite of doubling something. What is the opposite of that? What is the opposite of doubling something? Yes. What's the opposite of doubling something? What is the opposite of doubling something? Single, you go. Oh, I can see people trying to struggle with English because it is called the half. Someone is like halving. Someone is like it's not there. And someone is using my name in the chat. And that person is confidently giving wrong answers. Now, which blackmailing is better than that? You're using my name and you're giving us wrong answers. So what do you mean? Okay, the opposite of double is half, yeah? So the opposite of doubling is halving. So the person said halving, that's wrong. It's called halving. Yes, it's halving. Halving. You can check the internet. I don't know if that's right English. Let me also check right now. Someone check with me. Is it halving or halving? For me, I know halving. Halving, I'm here, I'm learning it from Zoom. And you can see the person who is writing, actually, it's halving. Halving does not exist. And the person telling us that is called Camila. But when you read the name Camila, you may be like, maybe I'm the one who is wrong. uh-huh. Okay, it's halving. So this is what we do. You note this. You note this. We shall see that later. We shall confirm later. But I'll tell you why I'm telling you this. Why I'm telling you this, because you also have what we call half angle. Yes. Okay, so when half angles come, I'll tell you the relationship between doubling and halving. I have seen someone talking about my former school. Yes, my former school is that one, Kaboja. But that was from primary 4. From primary 4, when I left a certain school called Savio Junior, then I went to Kaboja. Yes, I also went to Taiba International. They were good schools, so my foundation is a good one. That's why I try to speak some English. Yeah. Okay, back to business. Let's begin with sine as usual. So what do double angles mean? So people think that doubling is only 2, 2, 2. No, it's not only 2. It can be something else, as we are going to see. Now, let's begin with something like sine 2a. Yes, sine 2a like that. What if they ask you to handle something like that, sine 2a? So you need to first understand where that is coming. So when they say sine 2a, because of this 2a, you should at least appreciate that 2a is the same as a plus a. That is one thing. So after appreciating that 2a is a plus a, now you apply what we called our compound angles. Even when that angle is the same, now you stubbornly apply it. That's what we do. You get, now stubbornly apply compound angles. Break the 2a down into those two. The sine a plus a. Because a plus a will take us back to 2a. So no rocket science there. Okay. Now, after doing that, you now be like, what do we do? So for sine, we always have sine cos, isn't it? Then even this side, we always have sine cos. So the angle is A throughout. So we don't have AB, we have A and A. That means everywhere is going to be A. This one A, that one A, and that one A. Because of this plus with sine, we maintain this sign. So this one will also be a plus. Nothing has changed. So you realize that this is the same thing, and it is the same thing here. So it's like you're getting x and you're adding x. What do you get? 2x. Because it's the same thing, don't you see? It is sine A cos A. Even the other side, it is sine A cos A. So it's like you're adding x to get to x. So that's where the conclusion comes in, and you'll be like, oh, sine 2A. But what was our last lesson in mechanics? I've recalled we talked about this when we are talking about projectile motion. What was our last lesson on mechanics? Because now I have missed mechanics. So this will be 2 sine A cos A, like that. I want you to look at that. If I told you okay with sine 2A, you write in the chart, we go to cos 2A. You write in the chart, we go to cos 2A, 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 like that. If I told that one is fine with you. Someone is like, let's go. Okay, let's go. Okay, so we go cos 2A. And you should be very careful with trigonometry. It is that one branch that can be used to generate very good scenarios. Very good scenarios, because it is good at solving problems. So you should be very careful with trigonometry. So cos 2A it will be cos. Then instead of 2A, we shall have A and A, like that. Now, after having A and A, now you go back to the compound stuff and ask yourself, how do I deal with cos of the angles being added? You get? You recall that for cos it is cos, then sine, like that. I will say that I'm having cos, then this side I'm having sine, like that. So the angle is A and A, no other option other than us having here, A here, A here, A there, and A there. Then you all know because of this plus, we shall have what? A negative. As simple as that. Then you all know x times x will give us x squared. So we are having cos A. So this one is cos A, and you all know it is squared. Then this side, what do we have? We are having sine A, and it is appearing twice, so it is squared. But you all know that in trigonometry, we don't write it like that. We don't write it like that. We just write it like that on a calculator. But if at all we want to come up with the rule, this one is cos 2A. So this one becomes, how do we write it? Cos squared A minus sine squared A. Like that. So now, I do this. Is that okay? People, is that okay? The one of course. Is it also okay? And no one will ask you to derive them, but you need to know. But those of 3A and sine 3A, those ones you need to know how they come about. But you cannot understand them unless you understand these ones, trust me. So that's why we are beginning with these ones, then the rest will come in later. Okay, that is good. Okay, now, I want you to recall something. And what is that something? We are going to part ways. We are going to part ways. So what are we really going to do? I want you people to recall that from this, from the first identity, which says cos squared A plus sine squared A equal to 1, you all know that cos alone can be 1 minus sine. I don't know if you people are aware. Then you all know still from that same thing, sine alone, you all know that sine alone can be 1 minus cos A, like that. So what I'm going to do is what they call substitution. So I'm going to maintain my cos 2A. Then where there is cos squared A, I'm going to come and put the 1 minus sine. Now if you people are following, then I'll leave the other one as it is. Are you following? Then for this side, I'm going to leave my cos 2A. I'm going to leave my cos squared A, but I'm going to remove the sine and then put 1 minus what? Cos squared A, like that. Then if people are following. Then when I proceed, I'm going to come up with two new equations. The first one is cos 2A. I'm having 1, then this one is like minus x. So that will give us minus 2x. You understand? So this one will be minus 2, and what is our x? The sine squared, like that. That's another formula, still of double angle, because it is an expression to cos 2A. Then this side, I don't know if people are noticing this, that when you open brackets, this one has some working to proceed. So it will be like this, minus 1, but again plus because of negative and negative. So cos plus cos is 2 cos. Then minus 1 will come at the end. So you just need to have that keen mathematical eye for you to see some of these things. So you can see the x plus x giving us 2x, which is 2 cos that. And then the minus 1 will come at the end. That's another thing that helps. But all these things, they're not supposed to derive them in an exam. You should be knowing them. And I'm going to show you how those ones can be actually recalled. Yes, I'm going to tell you that. Now, you listen. Before I tell you how you can try to reminisce them, you first tell me whether they are okay, whether the derivation is okay. Those last two. You say that the one we got first, this one, the basic one, you said it is okay. It's the one that we actually have here in our logbook. By the way, all of them are there, sorry. So, we are having that. And we said from the first trig identity, we realized when we make cos squared A the subject, that's what we get. And we also realized that when we make sine squared A the subject, that's what we get. And then we try to substitute. Then we substituted for cos and we maintained the negative sign. We came up with this last one. Then this side we substituted for sine and we left cos. Then we came up with this last one. So you first confirm to me that the derivation is okay. Then I can tell you about how you can try to recall. Okay, you've said the derivation is very okay. That is good. Now, let me try to show you something, how you can possibly recall those two. So this is what you're supposed to understand. I want you to listen. That so these are hints, but they're just hints to make you recall. But I've derived for you. I've given you the real math. So these are bogus hints. They don't exist it, but they're just going to help us maybe recall we want. So let me give you the 3 bogus hints for this double angle of cos. So we're having cos 2a, we're having cos 2a, we're having cos 2a. And this is what you should understand. That everywhere we are having squared a. That for the first one we are having squared a minus, we are also having squared what? Squared a. What usually confuses is this thing. What is always there. Then even this one, you understand the other now, the last two, the ones we have derived, understand that there is that one which has minus 1 this side. Then there is that one which is 1 minus. So one ends with minus 1. Then there is that begins with 1 minus. You get a. Then you should also recall that what is this side will be something of course squared a. So squared a is everywhere. So even here, squared a. So you realize the problem is one, about who is going to be occupying those positions, the ones that are coming before squared a. So it's all simple. It's all simple. Because this one is cos, because this one is cos, because this one is cos, the only thing that can come immediately after its equals sign, because this is cos, the only thing that can come immediately after the equal sign is its brother, and the brother is cos. The only thing that can come immediately after the equal sign in the double angle of cos, because it is cos, that thing that can come immediately after the equal sign is the brother, and the brother is cos. So that means here we are having our cos squared a. Even here we are having our cos squared a. Then this last one, because it is even coming after, because what is coming immediately after the equal sign is 1 minus. So the other thing is what? Sine. Then lastly, what you need to understand, that in these last two, we have the 2 here, we also have the 2 there, like that. But this one is just like that. So even this one, since this one took the cos, this one will be the what? The sine. That is my own way of trying to recall. If it doesn't work for you, find yours. If at all you can't find yours, then make sure you learn the derivation so that in an exam you derive. But the best thing is to have a way you can derive it and also have it at head. But if all fail, you just go to the logbook. They are here. They are here. I told you this is an academy. I could actually just bring numbers and straight away, we do a number, we copy the formula here. We do a number, we copy a formula here. We get another number, we copy, but this is an academy. So I want to tell you how things come about, how we can memorize them. If my way fails, you get yours. If both fail, you now learn how they derive. If you can't learn how they derive now, you're supposed to use the logbook, provided you learn how to use it. Getting the formula from here, then you paste from there, then you paste like that. Hope we are together there. Okay, now, back here, back here. There are a lot of things. There are a lot of things in this trigonometry. But if you don't understand these basics, the things become very hard for you. Very hard for you. Very hard. Okay. People are not asking me questions. I don't know why. So one more time. Have it in mind, we have squared a for the first one. Then these other ones, it's either 1 minus coming first or minus 1 coming at the end. Then this other thing begins with a 2, begins with a 2. So every time you're having cos, just like it is here, the only thing that can come immediately after the equal sign is the brother to cos, which is cos. Then of course the other one will be taken up by sine, no option. Provided this is cos, immediately after the equal sign, what can come here is cos. Of course, the other one, we agreed it is already minus 1 as we said. And then, of course, this one will be taken up by the sign because cos is supposed to come immediately after the equal what? The equal sign. So if we begin with 1 minus, we are trying to take on a what? A sign. Like that. And trust me, when you don't know these two, then you're not going to understand half angle. Yeah, because we just reverse these ones to get half angle. You need to know that. Those two. I don't know. Brain test. Who can raise up their hand for the brain test? Who can raise up their hand for the brain test? As if I saw Fahad raising up the hand first. Yes, Walter. But I'm not seeing Fahad. Yes, Walter.
Good evening, doctor.
Yes, the first one. How can we fill it? I can see it's ending in -1.
So there we're going to put cos.
Cos. Why?
Because we from the trigger identity,
Okay, that's
from
okay.
the
Then
trig
the second,
it is cos.
then what? Then sine. This side also. You know why Walter
Sine.
is what?
Sine.
Sine, okay. People, that is it. So let that not confuse you. Let that not confuse you. Yeah. Even when they say cos to b, very fast, come and say this is cos squared b minus sine squared b. That is the first one. If you want 1 minus or -1, when you say -1, this will be 2 cos squared. It will begin. When you say 1 minus, it is coming far away, so it will be sine. But don't forget this 2 squared b. Don't forget this 2. Like that. If it is 2y, you know what to do. 2m, you know what to do. 2q, 2p, same things. 1 minus, it is sine, don't forget the 2. Minus 1 is 2 cos. Cos, don't forget the squared. If you want to use the basic one, is cos squared minus sine squared. Like that. Okay. Now, lastly is the one of tan. Tan 2a. So tan 2a, this one is easy. It is tan a plus what? Tan a, like that. And then you know what we do for tan. For tan, we said you set tan and tan. Then after that, you put here a 1. Then you come here and set tan tan. Isn't it? So you know what to put here. This is a, this is a, this is a, and this is a. And because of this plus, this will be a plus, and here it will be a minus. Then you conclude and have your answer. So for tan 2a, this one will be 2 tan a, 2 tan a, because it will be tan a and tan a, 2 tan a over 1 minus tan squared a. Yeah. And this is one of the things UNEB likes so much. Let me hope people we are at the same page. So even if they change their words and then say tan x, you should still be in position to also play on their minds. So when they say tan x, you also be in position to say it will be tan x and tan x, which will be 2 tan x. And since it is plus, like x plus x, that means down will be minus, so it will be 1 minus. And since we'll have tan x, it becomes tan squared x. You see? That is not hard. Not hard. So who has gotten the technique at first sight to tell us tan 2p? And you also tell us tan 2y. Yes, Mark, Britton Mark, something like that. Britton Mark.
For tan 2p,
Mm.
it is going to be 2 tan p
2 tan p.
divided by 1 minus tan squared p.
Tan squared p, yes. To save time also, the last one to be
It will be 2 tan y
2 tan y
1 minus tan squared y.
Very good. Thank you so much. That is it. That is it. That is it. That is it. So I think now you are getting the technique. Now I want you to see some sort of magic. The one I'm going to tell you now. We are going to go back to the beginning of double angle. I show you the technique that these people are using. Then I see few people can do the same thing. So I want you to look at the first one. Here, 2a became a. Do you see that? That here we had 2a, but the angles you have this side, it is a and a. Seeing that? So when 2a becomes a, we say that 2a was halved. If I stop there, then I got also this one. What do I also realize? I also realize that the angle was 2a, but in this side I'm having a and a. So the same thing happened. 2a became a. You can see that the 2a was what? Was halved. Okay. Then here the same thing. 2a, this side it's only a. Even here 2a, even this side is only a. So here the same thing happened. And here the same thing happened. I think it is the same thing. And now let's go to tan. Do you see also tan? This one was 2a, but out of the blue it became a, even here a. So the same thing happened. Even when you go to other angles, it is the same thing happening. Here it was x, sorry, 2x. And then this side it is x, even here it is what? X. Even when you come to what we have just done. This one is what? 2p, but here we are having p alone, p alone. This one is 2y, but here we are having y, here we are having y. So that means here the same thing is happening. Even this side, the same thing is happening. So I'm going to give you a note. Then we repeat with different angles. That's what will make you a good student of trigonometry. And that's what disturbs most people. But don't worry, we are done. Because now you can see I'm also going to come and tick these ones. Remember these ones we got done. Let me get my red ink and I tick. We are done. We are done. Trust me, the application is easy. What is hard are these basics we are trying to build together, so that we don't over panic into examples. But this one we got done, we got done, we got done, we got done, we got done. So remaining with only 2. And trust me, these ones are very cheap. If at all you've understood this and this, for them they are the easiest. But before we go to that, we are going to first handle some special cases. So we're going to put here a special note. That usually puts people off. Special note. In double angle formulae, the angle is halved. That's what we have been doing. And what do I mean by the angle is halved? We have all realized that the 2a has been becoming a. That's why I've been putting same. So this is the same thing we are going to be doing. That's the same thing we are going to be doing. We're also going to be having the angles like that. Having them. Because it's not a must that in double angle they always give you 2a. No, anything can be a double angle, anything. So it's not only 2a that is a double angle, anything else can be a double angle. So another note. Is not the only. I don't know what's wrong with today's network. Is not the only double angle. Is not the only double angle. Any angle can be used in the double angle formula provided we have it. Can be used in the double angle formula provided we have it. So provided we have that angle, any angle can be used in the double angle formulae. It's not that 2a every time, 2a every time, 2a, no. And why do we say that in double angle we always have the angle? We have realized that everywhere we had 2a on our left-hand side, on coming out on the right, it was coming out as a. Yet we are calling it double angle, so we are having the angle. So therefore we begin. I think this is what is going to make the point more clear and stronger. So therefore, what if you're having sine 4a like this? Well, let me first make you recall the first one of 2a that we dealt with, because it's the one that will make you understand. So recall that sine 2a is 2 sine cos a. So I want you people, let's begin with 1 sine 4a. You write for me the answer of sine 4a in the chat as I try to get another document. So our sine is that, the sine 2a is like that. So what of sine 4a? Oh, I'm seeing people struggling. People, our focus is only and only about the angle. Our focus is only and only about the angle, not anything else. Don't even stress yourself. It's only and only about the angle. So let your focus be here. Your focus should be on how the 2a is becoming a and a. The rest are constant. Yeah, the rest are constant. The rest are constant. So this side, what do we have? What do we say? We say that the angle is halved. So say that the angle is halved. Then the rest are constant. So these other ones are constant. You leave them. Yeah. Those ones are constant. Don't even touch them. The rest are constant. So when they give you something like 4a, please you come and write 2 sine, and then have it in mind that here we are going to have our angle that has been halved, like that. So when you have 4a, you get what? 2a. When you have 4a, what do you get? 2a. So that means you're going to just have the answer like that. Sine, 2 sine, 2a, cos 2a. So these are the things that make trigonometry hard. But realize you cannot understand them unless you understood the very first things. Because the first things that helped us to understand that the angle is what is halved in each of the cases. And then I've told you, let your focus be on only the angle. The rest of the things are constants. So as far as double angle is concerned, these two will never leave. It will always be a 2. And what we shall be having here as the angle is the result of halving. Then this one will remain as sine, even this one will remain as cos. And that is it. Okay, let's do another one. Let's do now sine 8a. It is the last one I'm doing, so you'll be sober. So for sine 2a, what have I said? I've said that the 2 is a constant, the sine is a constant, even the cos is a constant. Now the angle is the result of having 8a. When you halve 8a, you get 4a, like that. And that is the answer. Was understood? You raise up your hand, I put the teasers. You see, this trigonometry is about brain teasers. It's about understanding the concept, then brain teasers. I think the first person to raise up their hand, it was Ayob. So Ayob, where are you? Ayob, unmute. Are you ready? Why are you quiet, sir? I don't know why Ayob is quiet. I think let me choose another person.
I'm not quiet.
Then why are you scared? You speak.
Okay. It is the first number 3. Number 3 is 2 sine.
2 sine,
Sine 3 over 2x.
3 over 2, because when you have 3, you get 3 over 2. 3 over 2x,
Then cos 3 over 2x.
That is very good. And these are the things that make trigonometry hard. Thank you so much, Now, let me, thank you for that. Let me go for Rajo Polot as Danger. Danger, prepare for the last one. Yes, Rajo Polot.
Yes, doctor, I'm handling sine 3 over 2x. It is going to give me 2 sine 3 over 4.
3 over 4, because a half of the angle 3 over 2, it is 3 over 4, and so?
Yes. Then
X,
it cos,
then what?
cos 3 over 4x.
That is good. Where is Danger? My best friend for today.
Okay. There we are going to write 2 sine. 2 sine a half.
2 sine
2 sine a half.
Half b, very good. Or b over 2.
So then cos a half b.
Half b, thank you so much. So people, that is it. These things are not hard. Yeah? So don't be those kinds of students who think that it is only 2a or 2x or 2b that is a double angle. No. Any angle can be. Any angle can be. What you need to appreciate is one, that all we need to do is to have the angles. These things are constant. That is a constant. Then you should just need to know that if this is b, the angle here must be half of that angle. We should halve. You get? Same thing. You should just make sure that if this is 3x, the angle here is the result of halving. So you do what? You halve. Like that. You don't see anything hard there. Now, that has been about sine. I can call this part A. So be ready, others are coming. We haven't done anything. Okay, so I come here, part B. So So part B, these are things you're supposed to recall. Supposed to recall the first one, that cos 2a. So any person submitting, you give us answers for all. So remember, cos 2a has three things, and you should be knowing all of them. Hey. So the first thing is subtracting. So should just be having that confusion. Either it is sine minus cos or cos minus sine. But since you know that we are dealing with cos, it is cos that is supposed to come immediately after cosine because it's the brother to cos. Or you master the derivations. It's supposed to be like this. So I don't want you to be those students who are going to also put 2a here because they are forgotten. So as a student who has attended this lesson, you should know that as we are moving from 2a, we must have the angle and it becomes a, it becomes a. You get it? Then there are these two other options of either 1 minus, and I said when you say 1 minus, this should be a 2. And when minus 1 is coming at the end, of course it should be 2 something. So here, if this is cos, what can only come here at the beginning is the cos squared minus 1 like that. Then the sine is the one that can come later on like this. Or it always comes at the end. You can see it. It's always at the end. At the end. But for these ones that involve 1, never forget the 2. These ones that involve 1, never forget the what? The 2. Like that. I don't know if we are together there. I don't know if we are together there. Now, I'm also going to give you my theory. I'm going to do for you only one. Only one. And for me, I do easy ones. For me, I don't want to do hard things. For me, I'm going to do for x only. Then I give you others, you try. So to do the other one, of course, minus sine, don't forget the squared. So all these ones are constant. But the angle you're bringing, it should be half of this angle for x. So you say 2x minus, this one will be sine squared 2x like that. Then to bring maybe the one of 1 minus, don't forget the 2. And because it's coming at the end, this one now will be sine. Don't forget the squared. And the angle should be half of 4x, which is what? 2x. Then here, if at all I want to have minus 1 at the end, that means what is coming at the beginning should be cos, and I shouldn't forget a 2. And it should be cos squared, and the angle should be half of 4x, which is what? 2x. And then, yeah. You see that? I don't know if it's hard. Who is ready? Who is ready for number 2? Who is ready for number 2? Who is ready for number 2? I want someone who has not said anything. You give us 3 of them. Let me see if I have a new customer. You people, I cannot be having the same people submitting all the time. What of other people? I want someone who has not yet submitted. I want someone who has not yet submitted. Engineer Joshua. Where is he? Engineer Joshua, unmute.
Yes, good evening, Doctor and other guys. The first one is going to be cos squared x over 2.
X over 2, or what we can call a half x.
Yes, minus
Sine
sine squared
squared
a half
half
x.
x.
Then the second one
Mm-hmm.
is going to be 2 cos squared a half x
what you can write as x over 2 minus what?
Yes. Minus 1.
Minus 1. Then lastly,
Then 1 minus
1 minus
2 sine squared
2 sine
a
squared
half x.
half x.
Yes.
Very good. Very good. That is it. That is it. Not hard at all. Not hard at all. So, I don't know. Anyone ready to do for us this last one? Anyone ready to do us this last one? Yes, this one now has some algebra. That's what I'm testing. Let me see. Do I have any new client? Anyone who has not said anything to take us through that? So the rest of you are trying to write notes. Let me hope you also try out on your own and then later on confirm. So anyone who can do that for us and give us the 3 cases? Someone who has not said anything? Yes, Francis, but as if Francis said something. Okay, let me go with my best friend. Kemi. Yes, Kemi?
Good evening, Doctor.
Mm.
For the first case, I think it's cos squared 2 over 3x
You wanted to see that
minus
over 3. Yeah, very good. Minus
sine squared 2 over 3x. Then for the second one, I think it's 1 minus 2 sine squared 2 over 3x. Then lastly, 2 cos squared 2 over 3x minus 1.
Very good. Very good.
Thank you.
Yeah. That one is called Kemi, the one who makes the most noise in the group. So we call it noise with brains. Yes. She makes noise in the group, but she has brains. So that's called noise with brains. Those who don't know her, she's the one who makes the most noise in the group. Every time I go off and get back, at least I find her message. If she's not complaining, she's abusing someone. Sometimes she even scares people and she says, let me just keep quiet and control myself because I may tell you something and you may not like it. Students. How can you scare a fellow student? That I'll tell you something and you may not like it. Okay. So I think that has been handled to one extent that I'm thinking that even if we don't do that of tan, you now know how to deal with the halving and so on. Now, in UNEB, you see, we should respect UNEB because they're the same body that is going to be setting scenarios. But when you check UNEB 2023, paper 1, where trigonometry was already set, I think it was number 15. I don't know, it was some number there, but in section B, it was a number of section B. They asked students to prove. So those things in the logbook, they asked them to prove that thing of tan 3 theta. Tan 3 theta was asked in UNEB, and those are things we are going to handle. So have it in mind, the next things we are just handling just right now are those things that UNEB set. especially to prove those higher angles, especially these ones of 3. So we are going to do them, see some unit numbers, and then go through our workbook. Every question we are going to be finding, we are going to just be crushing, just crushing. Trust me, the things we have done, you're going to appreciate. Yes, you're not going to find it hard to understand any number. The things we have done, even if I just tell you, you go to any book that I'm going to give you to go through all examples that we have done. I don't know what's wrong. Yes, Francis. Why are people raising up their hands? I don't know. Is there any emergency in the chat? What's wrong? Yes, evidence.
Sir, I need I'm requesting for that screenshot of that previous page, the previous one.
Why are you saying Vanange? Can't you ask for it without saying Vanange?
But no. Okay, sorry, sir.
Okay, that is it. I'll talk to Kemi akuwe vivyo. Okay. What was I even saying? I've recalled. Okay. So this is how these questions usually come. They tell you that show that. So part A, hey, there is the one of course, can be cos 3a, it can be sine 3a. Like this. And you people, the way you're seeing them here is the same way they ask these things. The way you're seeing them here is the same way they ask them in an exam. But I'm going to give you a technique of how you can call them. Just cause for them, you see, this trigonometry has a lot of identities, but it's very easy. I don't know, but personally, I find it easy. Maybe because I'm doing a short course in applied trigonometry. But I see them as very obvious. Let me see how we can easily recall this. So this is what usually happens. So have it in mind that for cos 3 theta, we have the cos 3 theta like that. Then the 3, sorry, for cos 3a, we have the cos cubed a and the 3 cos a. I don't know if you get that. I don't know if you see the difference between the two. Then even for sine, that one, we have the sine cubed, this is 3a. We have the sine cubed a. Then we also have the 3 sine a. You should understand that one very well, very well, very well. Now, this one is already having its coefficient 3. They already have their coefficient 3. But these ones don't have the coefficients. So the coefficient they take on is 4. So these ones have a coefficient of what? Of 4. Then the other thing you need to understand that they are subtracted. What separates the two is a subtraction sign. You get? But now the problem is usually on which one comes first, which one comes at the end. That is usually the only problem. That is usually the only problem, nothing else. Nothing else. And if you can just understand that, then you'll be very safe. Very safe. just repeat for you here. We are having cos²θ. Let me use theta now. So there is also sin²θ. I've said they have two things. They have the cubed theta. They also have the theory cos²θ.
There's nothing playing.
You get this one, the same thing. It has the sin cubed theta, then it's having the sin²θ. So you may maybe say this theory can either go up as the cubed or it comes outside as the coefficient. This theory can either go up as the cubed or move out as the what? As the scalar. So these ones already have their scalar or coefficient 3 out, but these ones don't have. They also take on what? Their scalar or coefficient as 4. Now these ones are separated by a negative sign. But what is the problem is about which one really is coming first, because they cannot follow the same path. Never. They cannot follow the same path. They cannot follow the same path. Never. But both of them, it is separation. So now this one usually disturbs. Be like, which one is really coming first? And I don't know whether my method that used to work for me those days can work for you. What can we say? What can we say? Okay, someone tell me. For cos, it's like the way you're seeing it here. It's 4 cos cubed theta minus. You get? So for it, it's just like that. But for the case of sine, it is minus, but in this direction. Do you see that? So I've said that for cos, it's like this. So master this, I'm going to write it. So it is the cubed first for cos. But then for sine, it is the cubed coming last. How sure I used to recall it, maybe. So I've said that for this cos, it is the cubed that will come, and you all know that the cubed is having the coefficient as 4. Then they are separated with a minus. Then the other side we said cos. Like that, that's what we said. Then for sine, it is the reverse. For it, it is beginning with 3, saying this, then minus the 4, sine this theta. But remember, for me, I'm teaching you how you can learn it. I told you this is an academy. But if at all, it may give you a time, it is here in the logbook. It is here in the logbook. It's there in the logbook here. These two. And I'm also going to tick them because we are done. I'm only remaining with just proving them. But you can see that at least the 3a, they have the cubed part. They have the cubed part with the coefficient 4 or scalar 4. Then they also have this 3 sine, the 3 cos A. And they are separated by minus. They are separated by minus. But the problem is about which one is coming first. When I see people raising up their hands, I get disturbed. Yes, Angela, what's the problem? Any problem?
Yes, I've not understood how you split it.
How what?
How you split it, both of them, because I'm seeing 3 sine.
You're not getting what?
How you have split them.
Oh, okay. Okay, I'm going to talk about them again at the end. But let's first have that. Let's first have that. So people, now about the real trigonometry behind all this, because I've told you most questions tell you and ask you to do what? To show. Not just, so you don't show like they have been showing, yeah? So that way, that way of showing is the local one. That is mine. You don't find it anywhere. You've just been trying to deal with the examiner traditionally. But now what if you're supposed to write the real trigonometry? That's where the question is. And I told you you should have understood the 2a and the a for you to maybe understand what we are going to do just right now. So for me, I'm going to do only part A, and you people are doing part B, then you tell me whether it's coming out. What I've been doing, I've just been trying to show you how maybe you can do it. Yes, maybe how you can do it. Now, we are going to struggle with it. So I've said I'm doing part A. Someone is saying that you're not seeing my screen. Is it true? How come yet I'm sharing it? Where is 4 coming from, doctor? 4 is coming from where, please? You have paused it. Oh, I've just paused. Okay. I think it's now back. So people are confused where is the 4 coming from. So people didn't get that I was giving you the local way of trying to reminisce everything. Yeah, by reminisce I mean recall. So let's now do the real trigonometry. Yeah, maybe people have not appreciated my local ways. Let me take away my bogus. Now let me begin. Let me do the real trigonometry. So let me respond to part A. People will respond to part B. People have chased my local ways. So they want us to do cos 3a, not so? Cos 3a, like that. So remember when we were doing cos 2a, we said a plus a. So as we are doing cos 3a, we are going to split it into 2a and a. It is better that way. Don't say a plus a. That one we have not even tried it, so it may be stuck. But at least you can do the 2a and a because you know what 2a has and you know the a also. So it is very easy. So after that, you now do the needful. What do I mean by the needful? You come and say, okay, this one is cos, not so? Cos. There is a sign here, then sign. Then sign what? Sign. So it is obvious. This one will be 2a, this one will be a. This one will be 2a, this one will be a. This one will be minus, sorry, this one will be plus, this one will be a minus. Are we together there? Are we together? After that, we are going to remove the 2a because we know what 2a means. But remember, the question wants us. I want you people to listen here carefully because I'm going to make weird substitutions. Remember, where we are going, we don't have any sign. We are only having causes, yeah? Only causes. So you tell me, I'm now supposed to replace for this cos 2a. But remember, cos 2a has 3 things. If you've been following me, cos 2a has 3 things and they are here. Which one are we taking? Remember where we are going, we only have causes. And we have reached a point of substituting for cos 2a. Are we taking the first one, the second, the third? Now I've started teaching you the techniques in trigonometry. Cos 2a is having 3 things that it is equal to. And now we have reached a question that is asking us to prove. But remember what we should show finally has only causes, it doesn't have the sign. So which substitution are we going to take? The first one, the second one, the third one? Which one are we taking? Which one are we taking? Which one are we taking? We cannot take the first one. We cannot take the first one. Blessed daughter, we cannot take the first one because it's having sign. And we don't need sign in what we are doing. So it is out. It is out. Get the point? So I'll come. So I'll come and then say I'm taking the third as you people have said, which is 2 cos squared A minus 1. This one is cos A like that. Minus, you all know sin 2A, that one had only 1, so you don't overthink, you just put. So the whole of this is the sin 2A. Then don't forget that the other one was already there. Yes. Like that. But you're not supposed to forget that where you're going, it is only courses. It's only courses. The moment you forget that, issues. Yes. So things will have to cost you, like it or not. Okay. I think we are back. So you can decide to rearrange this and say, this one will be cos A into 2 cos squared A minus 1, then minus, I know if people are seeing this and this, sine and sine, that means sine squared, so it will be 2 cos A, and then this one will be sine squared A. But remember, where we are going, we don't have any sine, so I think we can remove this sine. You know, if people are aware that sine is the same as 1 minus cos. So when I come here, what will I have? I will have 2. This one is now cos cubed. You know, if people can see that, then this one will be minus cos A, just that. This one will be 2 cos A. This one is 1 minus cos squared A. Do you see that? Why are we doing this? Where we are going, we don't have any sign. So we should find ways of ignoring the sign and eliminating the sign we have in any way possible. So we proceed. What do we have here? We're having 2 cos. This is cubed A. This one is also minus cos A. Then this one is minus 2 cos A. And then you said trigonometry is hard. This one is now plus 2. But cos what? Cos cubed. So I don't know if people are seeing the 2 cos cubed. This one is 2 cos cubed. Even this one is 2 cos cubed. Are you seeing that? Hey. So that one will give us 4 cos cubed. I don't know if people are seeing this. Minus cos A minus 2 cos A, which will be minus 3. Like that. And you all know this is an equivalent. Cos 3A. And then after that, you can put for them the word as required. That's what normal students put. But then the extraordinary students, they always begin their work like this. Is equivalent to cos 3A. Then after they get the value of cos 3A, and then as they end, they also tell us that this is equivalent to the right-hand side. Then they conclude by telling us that left-hand side is equivalent to the right-hand side. So you just do your work normally. You leave this wiseacring of mine. Do your work as normally, put as required. You get the same marks like me. I'm just a wiseacre. So, is that okay? But as you tell me it is okay, have it in mind that you're the one to respond to part B. So when part B comes out, you just be like, it has come out. That's all I want to see in the chat. And I'll give you just 5 minutes because it's the one I've used. And have it in mind, when you pass the 3A, that means we shall have ticked all of them. And the lesson will have been a success. The rest of the things are going to be obvious. You're going to see. What makes trigonometry hard are the things we've been doing. And if I've tried to show me the things are very obvious and okay. So that means I'm not scared. Things will come out. So after that, we are going to do the half angle. And you know that half angle is the reverse of double angle. If it's the reverse, so that means in half angle, what do? We double the angle. Which we double the angle, like that. So I don't know if people have any questions. Those were asking me, Doctor, where is the 4 coming up from? What about cos 8a, such a quest? I think you can also, I think for triple angles, those ones, they just set them like that. This is now an identity of triple angles, so don't expect anything outside that. So for triple angles, for those ones are like that, and there are only those two. The one of tan 3a, that one is very easy, provided you know these ones. Yeah. You people, you're the ones doing sine 3a, and I'm waiting. I think we have tried to do it together. If at all any step is not okay, you tell me it's not okay. We repeat. You raise up your hand. You tell me, Doctor, this step where we have this, and this. I'm not getting it. If you're getting it, well and good. That is so good of you. Then if at all the steps have been okay, as you calculate for part B, you leave for me a text in the chat and tell me part A is okay, I'm working on part B. So someone, a good Samaritan, should write that message so that the other people just copy and paste. So a good Samaritan, write in the chat that part A is okay, I'm now working on part B. So that the friends copy and paste the message, as we hear from Gladys Gift.
Some inquiry. How getting sine squared A equaling to 1 minus cos squared A?
The first trigger identity. Have you forgotten the first trigger identity?
I've recalled it.
We actually have it somewhere. If the second part comes out, you tell me in the chat that second part has come out. Second part has come out. Second part has come out. If the people reach 5, we go to the next thing. Yeah, 5 people are enough to represent the rest. So I think the people I think the people have tried to, let me first get this math paper. You see 2023. I think the people have tried to bring it out even more than 10. I want to put that UNEB number I've told you of 2023. You do it. You do it also because I think people are trying. People may think we are wasting time. Yes, but I think when you do a UNEB number, you will appreciate and be like, oh, we are now doing UNEB numbers. Oh, thanks to doctor. So let me hope you're seeing my screen. So UNEB is the same body. UNEB can say, let's now get all the questions we have been setting in old curriculum and convert them into scenario questions. Yes. So when it decides to convert them into scenario questions, you're gone. The number is, it was number, you see 15. I told you I have a very good brain. It is here, 15 part A. You do it and tell me if it's going to come out also. Yes, you're not good at doing assignments, so I got for you a technique. You do assignments from class, so that when you leave the lesson, everything has been covered. Assignment, and also give you miscellaneous assignment. So don't mind about this. Don't be like, hey, doctor, but we cannot do this one. This one is factor formulae. And factor formula also needs its own time. Actually, its own lesson. We aren't going to even do it today. That one will be next time. Yes, I may even decide, I don't know, but I may decide. That's because the students who don't do math may start shouting for us, but I would also make tomorrow a trigonometry day so that we complete it, and we know trigonometry that students have over complained about is done. So we are doing part A. Yes, this is now tan 3 theta. They want you to show that it is this one. Hey, you see this mathematics where you may think you've understood, yet you've not. Hey, that's the only problem with math. For you may be there thinking, I've understood. But my dear, hey, you've not understood anything at all. Okay, I'm waiting. I'm waiting for messages in the chat like it has come out, 5 marks secured, 5 marks bagged, like that. People, that thing should come out very well. Very cheap. And that thing can be converted into a scenario, and a good one. Let me hope people here can do number 16. By the way, I'm going to use this very chance to show you that I've actually taught you people. And you can do a unit paper and pass. I'm going to use this chance and take you through the unit paper of 2023. I show you that you could get a 90 just by using my Google Drive. I'm going to use this chance so that if I tell you that bye-bye, you're like, yeah, it is worth it. I don't know, you copy the question very fast. You're wasting a lot of time. You have some few things to do before we conclude. Yeah, you do that one, tan 3 theta. That's what your neighbor wanted. Very sweet question that comes out very well. And also show you that you could get a 90% from a unit paper by using my Google Drive. Yes, you have the drive. So if I'm saying something that is not right, if I'm telling a lie, you'd be like, but doctor, you're lying. And I'm very sure. Even more than 100. I'm seeing a message. Site is out, Haman. Please, if it doesn't come out, you tell me the fact, because you may follow bandwagon and then I assume things are okay, yet they are not. But trust me, provided you split it into 2 theta and theta, then where you have tan 2 theta, you put there the 2 tan theta over 1 minus tan squared theta. That question cannot fail to come out as it is needed. It can't. Realize there is no even trigonometry. What is there is algebra. You're trying to deal with those things very well. People told me that part B came out, the one of Sin²θ. Let me hope it was the same for others, because there are people who are just quiet. They don't say anything. Maybe they follow silently, which is something good. But if at all you're not raising up your hand, at least you call me on WhatsApp during this lesson. I can mute and listen to you, then we explain. Yes. Or after the lesson you call, but I may delay to pick or to respond. That's why I always want it to end here. So that's a question. So let me hope the other one came out, because this one is like part C. I think I can feel the squeeze. I can feel the squeezing. People are getting squeezed seriously. Someone called cool. What do you mean? It has come out? That is good. I've read all your messages. Someone was like, it has refused. Then later they said it has finally come out. That was good. Someone has been like, habiganye, meaning that person has really tried and tried. Things have refused. So let me hope the one of okay, let me use this chance. Is there anyone who failed to get out the one of Sin²θ? Did the one of Sin²θ come out? Yes, I want some of you have been opening the chat and you've said it has refused. So the one of Sin²θ, did it fail anyone? Sin²θ. If Sin²θ failed, you tell me it failed in the chat. Sin²θ, which was the first assignment. Yes. Yes, those things are a bit technical. And I like it when people are open. So, the 3 people who have said 3A refused, I think there are about 4 people. So you're supposed to split 3A into 2A and A. That's what we said, isn't it? But you should have it at the back of your mind that where you're going, it's only sign there. And you know that the answer that you expect is 3 sin A minus like that. So you all know that for sine, it is sine cos. And you all know it will be 2A, then here A, then here it will be A, then here 2A, isn't it? And because of a plus here, even this one will be a what? A plus. Then we proceed. Sine 2A has no option other than it being 2 sine A cos A. So that is the sine 2A. But don't forget that there is also the other cos A. I meant cos A, sorry. So this one is a plus, then this one is sine A. Now the cos 2A, you know it has 3 of them, but we are choosing 1. Remember where we are going, it's only sine. So we shall go with the 1 minus 2, because it's the one that is having the sine. Like that, isn't it? So what do I get? I get 2 sine A, then the cos squared A, plus, this one will be sine A, then minus the 2 sine cubed A like that. So I am now supposed to remove this cos because where I'm going there is no sine. Sorry, there is no cos. So I should get rid of any cos that I have and I should avoid cos at any costs. So this one will be 1 minus sine from the first trig identity. This thing is very cheap, yeah? Though the last one is the cheapest. The one that has defeated people. Hey. So I think you can see that when you reach that step, the work is actually done. Nothing much there. So I'll come and just now open the brackets. I will have my 2 sine A, then minus 2, another cubed, like that. Then you can see this is sine 2A, this is plus sine A. That's what gives us 3 sine A, positive of course, Then what else? We are seeing this -2 sine cubed and also -2 sine cubed. So it gives us -4 sine cubed. And this one is A. And that's how. So the 4 people who told me that 3A refused to come out, is it now okay? Is it now okay we handle the last one? Then those who tried to bring it out, let me hope it wasn't by chance. Let me hope you also had similar steps like mine. Okay, now I think we can handle the third one. Now let me first clear something. I've seen someone in the chat saying that how many minutes to time. For me, I don't work on time. I only work on starting time. I don't work on ending time. For if you feel like anything inconveniencing has come up, you just go, wait for the recording, begin from where we stopped. I know this is an academy, not a school. So when I see someone asking when we are leaving, for me, it just piss me off. Now, what do you want me to tell you? We are leaving when I'm done with what I'm supposed to cover. So I can't tell. So tan 3 theta. So you had to split the 3 theta into this like this. That was the very first step. Then you recall what I said. That for tan, you'll have tan, isn't it? Then you know that down, you'll have the 1 and then also the tan. Then because of this plus, we said, shall have plus there, we shall have here down minus, isn't it? Then this one will be 2 theta, this one will be theta. This one will be 2 theta, this one will be theta. So you check if we have similar workings, those who tried out already. So you all know that tan 2 theta, you know that it is 2 tan theta over 1 minus tan squared theta. So this one is plus tan theta, isn't it? Then out of 1 minus tan 2 theta is 2 tan theta over the 1 minus tan squared theta. Someone may be like, but where are you getting that substitution for tan 2 theta? That thing we began with in the beginning. Somewhere when we are trying to cover the double angle. That is something we are trying to cover. So even if you come and check here. Okay, I think I've skipped. Wait, I don't have that thing. Impossible. It's here, I think you can see. Tan 2a, we had tan 2x, we had tan 2p, we had tan 2y. You get, so you just go and substitute. But if you really want to show them how it comes about, now that's what they call being disciplined mathematically. But if I just put it there, I'm indisciplined, but I'll get the same marks as yours. Yeah. Now you can first let me consider the numerator alone, and then consider the denominator alone. Whichever you want. You can just do them from that very thing, or you just say numerator. The numerator, what will I have? To tan this over 1 minus over 1. Then what will I have? Down I will have 1 minus tan squared theta. Then this one will be 2 tan theta. You get? If at all you people know how to add fractions and so on. So I really don't think that this can be a problem. 2 tan theta plus this one divided by 1 is that, then you multiply it with tan, I don't know if people get that step. I don't know if we are together, people. That when you get the whole of this, because of this and this one is the LCM. So when you get the LCM, divide it by this, you get 1. 1 times this one is that very thing. Then this one is the LCM. You divide it by 1, you get the LCM. Times tan, you get this. Tan times the LCM. I know if we are that page together. Then we can now start simplifying. So you can first handle the numerator alone. What do you come up with? So yeah, it will be 2 tan theta plus tan theta minus, I think it is tan cubed theta over the 1 minus tan squared theta, like that. Then the numerator, I think you can see that we are coming up with 3 tan theta minus the cubed part, like that. Then out of the 1 minus, I don't know if we are together there. Where is that in a question? So I'm going to even show people another thing you could do and get the answer. But that is going to be at the end. Let's first proceed. So now let's now handle the denominator. That has been the numerator. Now denominator. This is alternative 1. So denominator, you can see it is 1 minus 2 tan squared. These two. This tan and this tan, they will give us tan squared. Then we shall have 1 minus tan squared. So I'll have, denominator is 1 minus, this one is 2 tan squared theta, then out of the 1 minus tan squared theta, like that. What do I get? This one is over 1. So the denominator is 1 minus tan squared theta. Then this one over 1 times 1, it is that very thing. This one and this one, you get 1 times the top thing, it's the same top thing, squared. And then you get your denominator. You get your denominator as 1 minus 3 tan squared theta out of the 1. That is like that. So you'll have those two, and then that's how you survive. So a serious person can realize that you're having this one down and you're having the same thing down here. So it can cancel. So no need of bringing it back. So it can cancel. Because even when you divide and then multiply by the reciprocal, it will still cancel. So you can just leave it. Because it is on both the numerator and denominator, and it is down. So it can cancel. If people are getting me, just like you can have a over x divided by b over x. This x can cancel. Why? Because when you say this one, a over x divided by b over x, you then say a over x times x over b. So the x will what? Will cancel and remain with a over b. So the best thing is to just cancel it from this step and just remain with your a over b without wasting time. So it will cancel, and I remain with, on top I'll have 3 tan think people have, if you're serious, I think you've seen it come out already. So the tan theory theta, in the numerator, we are only remaining with 3 tan theta minus the cube, 3 minus the cube like that, over, now this one is just 1 minus 3 tan squared. So when you go back to the question, you now have the denominator, it's here, the way it was requested for. But now in the numerator, they pulled out tan theta. So you also come and pull it out, and then get what those people really wanted. So you'll have the tan theta pulled out. So what will you have here? When you pull out tan theta, what has been that one remains as this, then over the 1. Okay, I'm seeing some of you saying, wow, you're just yawning in the chat. But it was a bit long. You can see that it just needed the algebra. Now, what if someone really wanted to use the other first approach? Or what if you wanted to use these other things? You see, this trigonometry is very rich. Let me give you an alternative. Because we have the formulae in the logbook. So they can allow you to just paste everything there. So alternatively, when you check your logbooks, we have those formula of the triple angles. I think it is formula 2021. So they are allowed. You can use them. So yeah, that question gave you this one. So you could just say this one is 3 theta out of cos theta, isn't it? Then you be like, this one from the logbook, you go and copy from formula 20. Or if you know it at head, as I told you, you just come and write it like this. I don't know if people have been following. This is what I gave you. And so, Pure mathematics is very rich. So what if someone used that approach? But remember where you're going. The UNEB question. Are you seeing this car one? This car one. This one is a 1. Hey. And I told you about that one. Who can unmute and tell me what can I divide throughout with to create a 1 there? Which statement can I have there? What am I dividing throughout with to come out with a 1 there? Yes? Yes, Gladys Gift.
Doctor, you're going to divide through by 4 cos 3 theta.
4 cos 3 theta, are you sure?
No, it's 4 cos cubed theta.
Thank you. That is it. Then I'll proceed and say this one will be this one will be 4 cos. So I'm having, hey, you're now going to solve it. We are going to struggle. Hey. Teach a certain technique. You can first proceed. Like this. Now, to make matters worse, we are coming up with a very weird fraction. Are you seeing this fraction? 3 over 4, 3 over 4. Which may be a bit hard. Yes, which may be a bit hard to deal with. At some point, it may be a bit hard to deal with. So my advice is, if at all realize something like this, you can continue with this and actually get the same answer. But I'm telling you this as your trainer. You can now first leave the 4. Leave the 4. You say, now I'm not going to divide by 4 because the 4 is creating a fraction 3 over 4, which is hard to deal with. So you divide throughout by cos what? Cos cube. Don't be like, but I will not create a 1. The 1 will come. The good thing 4 is a whole number. So the 1 can come anytime. You just watch the space. So I don't know if you people have a very keen eyesight. I don't know if people are seeing the 3 sec. Who can raise up their hand and explain to us how the sec squared is coming? Then they are remaining with only and only 4. Then I'm having 4. Then this side I'm having that's what I'm having. Yes, Rebecca, tell us.
The sec squared theta comes because if you see in the numerator, I have 3 sine theta over cos cubed theta, and then the denominator I have 4 cos cubed theta over cos cubed theta. So the cos cubed theta for the numerator and the denominator cancel out. And whenever I have a sine over a cos,
That's where I want. Do you realize I've forgotten something?
Yes.
Which is a tan, isn't it?
Yeah.
That's what I wanted. That means we will also see this. And that's the problem. Some people are just accepting. They were just accepting. Like, doctor, we have seen it. Let us proceed. Thank you for seeing that. So I've forgotten a tan. And then here I'm having sec squared. You explain it again. You have refused?
Doctor, I'm seeing the tan.
You're not seeing the tan?
No, I'm seeing the tan, but the sec squared.
But the sec, eh?
Yes.
Okay, let me show you. Let me write the 3 alone. Then I write the sine theta. Then I write it with one of the causes. So the causes which have been there have now remained 2. On top I've remained with only 1. Then down I'm remaining with cos squared theta. Do you now see the tan and sec squared?
Yes.
So this is 3, this is tan, then this is sec squared. Because 1 over cos alone is sec. So 1 over cos squared is sec squared. You understand?
Yes.
Then here I will have 3 cos and 1 cos, then it cancels. Then I'll remain with 1 on top, then a cos that is squared. So that cos that is squared is the one that gives us what? Sec squared. Do you see that?
Yes, I see it, doctor.
That is good. So stay on, we are still going together. So remember where we are going, we only have tan. So we should get rid of anything else that we have that is not tan. You get the point?
Yes.
So I'm going to remove the sec and put tan using the second identity of trigonometry. So I'll come and say that this will be 3 tan into what is sec? Sec is 1 plus tan, isn't it? Second trig identity.
Yes, doctor.
And this is minus. But did you see where we got the minus 4?
Yes.
Let's correct this one also. Do you know what that one is equal to?
Only the numerator.
No, both of them. Sine over cos but cubed theta. What do you get?
You get tan cubed theta.
That is good. Tan cubed theta. So we shall come and then say 1 bit like that. Out of, then down. Do you see that these two cancel? This one cancels with that one. You only remain with 4.
Yes.
That means this one is right. This one is 4 minus 3 sec squared. But remember, we are supposed to remove sec and find ways of involving our tan. Isn't it?
Yes.
Good. So we proceed. So what is coming out here? Don't forget theta here. So we have 3 tan theta plus, this one is 3 tan cubed theta, then minus 4 tan cubed theta. Isn't it?
Yes.
Proceed over. This one is 3, 4 minus 3, then minus 3 tan squared theta. Are you following?
Yes.
Then we proceed. This one is the same as this one. So it's like plus 3x minus 4x. You get minus x, not so?
Yes.
We shall have minus tan cubed theta over 4 minus 3 is a 1 minus 3 tan squared theta. Do you see that?
Yes.
Then on top, I pull out the tan theta. Then you remain with only 3. Then what has been tan cubed becomes tan squared but theta. Then my denominator is left intact. Like that. Do you see that it's also bringing out the same thing?
Yes, I see that.
So which one do you choose? The first one, the second one, or both?
I prefer the first one.
The first one. Do you see that this one is hard because you have to reach a point of dividing throughout where you think it goes well. Then it is
Yeah.
also having those technical parts. So you
That
choose
require keen
wisely. Have
eyesight.
you had?
Yes.
Okay. Thank you for teaching the number with me. So, people, which one do you prefer? Which one do you prefer? The other one was like the normal ones, but it also had its serious algebra. Then for this one, we are using the triple angles from the logbook, but it's also having sensitive parts. But for me, I prefer the second. I don't know for you guys, but me, I prefer the second. I prefer the second. I just don't like the algebra in the first one of splitting the numerator and denominator. But it's also fine. I think people prefer the first one. But let me hope you people saying the first one doesn't mean that you've not understood the second. Let me hope at least you've tried to pick something. So there are things you're supposed to repeat on your own in your free time. You try to repeat them and see. Yes, you try to repeat them and see if things really come out, if really things are coming out. Something like that. Yeah. Something like that, something like that. So you're going to see that after whatever we are doing, I'm going to be exposing numbers and then I ask you to go through. You're going to see that things actually are coming out, things are making sense and everything is just okay. You're going to see that things are easy. So after that, we are going to deal with now the half angles. But trust me, half angles are very easy. They are the easiest. Second is too bulky and takes time to understand. Yes, because it has those weird stuffs. You're supposed to bring in triple angle. You're supposed to find out what you're going to divide throughout with. But the only technical part is here when you divide throughout by the cos cubed. And you saw that part where I eliminated the 4. Because I came up with a very weird fraction 3/4. So to avoid it, I removed the 4 down. Then the K1 will bring it off later. So things are not easy. Yeah, it involves a lot of splitting and coming up with the right fraction. But make sure you've gotten it because it is an application of a lot of proofs. They can tell you to prove something and they tell you to stop somewhere where you don't have the final answer. So you're supposed to be, you must have followed both. You should repeat both in your free time and make sure they make sense. Okay, now half angles. Half angles, these ones are only 2. You see, when I write the heading, you may think it is something serious, but they are only 2. What are they? From cos 2a equaling to 1 minus 2 squared a. I don't know if people have enough sight that can show them. Okay, let me try to be brief. Sorry, let me try to be detailed. People may get pissed. So this is what I mean. I'm going to first now bring this and take it this side. Then I take this one the other side. So I'll say one. Anyway, no. Let me not do that. Let me not do that. Remember, I need, I'll bring this one alone. Now take it the other side. Then I'll bring this one this side. So I'll have my 2 sine squared A. You see that? Then I'll have 1 minus cos 2A. Like that. Do you see that? Then to get the value of sine squared A alone, I will have my a half into 1 minus cos 2A. Now this is what they call the half angle of sine. So don't think it's a very big topic. No, that's what they call the half angle of sine. That is it. Then if I need that one, of course, I'll use the same formula. I told you there are the other two we reverse to get the half angle. So don't think it is something big, something serious. No, it's just bogus. So from the one of cos, maybe the cos 2A, which is 2 cos what? Cos squared A minus 1. You see that? I may say, let me bring this and carry it this side. Then I will have plus 1 equaling 2. You see that? What does that imply? That implies that if it is now cos squared this one, it will be a half. Yeah, it will be a half. One plus. Like that. And then this is what they call the half angle of cosine, or the half angle of cos. And there are those ones, nothing else. Half angle of cos or the half angle of the cosine. And there are just two things to notice. And they are the ones we are going to use to cut a word on them. So we are seeing A became 2A. I think you can see. This was A, but it became what? 2A. Is that really hard? What else do you see? A became what? 2A. So A becomes or became 2A. So when A becomes 2A, I told you this is what they call doubling. So A is doubled. But remember, it's doubled, yet we are dealing with what? The half angle. Then here, still A became 2A or becomes 2A. So this is what they call doubling. Remember, we are doubling when we are dealing with half angle. But then there are those of you who recall that with double angle we have. So do you get the relationship that when you're dealing with double angle, you will have the angle. When you're dealing with half angle, you're now supposed to double the angle. As simple as that. As simple as that. Hey. Half angle, we double the angle. Double angle, we halve the angle. Simple as that. So let me put for you the notes that I asked my question. So now we have it, or we now know that in half angles, or in half angle formulae, The angle is doubled. The angle is doubled. Yeah. Any angle can be doubled. So there is nothing like we only double A or we only double X. No, any angle can be doubled. Yes, provided you double well. We can put it in enough angle formula. So before I ask you my questions, I want you people to respond. Are those two okay? Are you okay with those two things of half angle? Are you okay with the half angle of sine? Are you okay with the half angle of cos? Before I tell you how you can cram them, how you can learn them by heart, you can see both of them are beginning with half. Both of them are beginning with half. You get? Eh? Both of them have brackets opening and closing. Both of them have brackets opening and closing. Both of them have cos 2a. Both of them have cos 2a. Both of them have 1. Both of them have 1. The only difference is with the sign. So since this is cos and cos, they are the same, so we shall put a plus. You all know same things positive, same things, same signs positive. But since this is sine and this is cos, then this will be a minus. I don't know if you people understand. I don't know if you people understand. So with those two, even if they apply them where, you'll have to understand by force. So I think when we apply them, you'll be in position to get everything. Yeah. Okay. Now, this is sine squared. I want someone to raise up their hand and tell me. Now, some of you are not good at following. There is something that I've said which is here for both. Then there is something that I've said that is here for both. Okay, so there's something there. Then I've said both of them have brackets like that. Then I've said there is something here for both. Then I said there is something here and there is something here. Something here, something here, something here. Yes, I think it was Gladys Gift to raise up her hand first. Yes, Gladys.
The first box, it's a half.
It's a half for both. A half.
Then when you enter the bracket, the first box in the bracket, it's 1 for both.
It's 1 for both.
Now, for the sign, it's going to be minus because
You
we're
first
having
tell me the
different.
last. You first tell me the last things. First, put the things that are similar before you talk about the sign. What are you even going to say for the sign if you've not talked about the things coming last? Don't annoy me.
Okay, for the last one, it's going to be cos 2a.
Why 2a?
Because we are now doubling it.
Because we double the angle in half angle. Then what next?
So for the half angle of sine, we shall use negative since they are different 1 for.
And this is sine, this is cos, so negative. And this is cos, so we shall put here a plus. And what are we noticing? What has been A is becoming 2A, so we have doubled the angle on cos. What has been A has become 2A, so we have what? We have doubled. Yeah, that is good. That is good. So Rajopolot, where are you? We are now going for the brain test. Brain test. Unmute, are you ready?
Yes.
So I want the one of sine squared x over 4. And the one of cos squared x over 4. Hurry, hurry, hurry.
We are going to say for the first one, it is going to be a half.
A half.
Open bracket.
Open brackets.
Then now 1 minus cos 2 over 4x.
2 over 4x, which is x over 2, isn't it?
Yes.
Very good. Yeah. Then this one will be the same as the above, just because we replace the negative with the positive, isn't it?
Yes.
It is very good. Danger, unmute. Raise up your hand. Thank you, Polot. Where is danger? Danger, are you ready?
Yes, teacher.
Why are you scared?
I'm not scared.
You tell me those ones.
We're going to first write a half.
Yes, I'm following. But Radio Polot, when did you learn these things? Because you maybe are disturbing us when you knew these things already and you're here trying to pass our time and waste our time. Have you learned anything new today? You tell us in the chat as Danger is presenting. I'm writing a half.
Yes. Into brackets 1
Into brackets 1
plus
What do you mean by yes, Radio Polot? One plus. Have you said plus or minus?
I've said plus.
Plus, cos
of 5 out of 2.
Are you sure? Hey, you see you have forgotten. Are you sure it's 5 over 2?
No, teacher, we double the angle.
We
It's
double the
10.
angle, 10.
It's 10b.
You told me you are going to be sober up to 3 a.m., but you're just dozing off just at midnight.
No, teacher, I'm still sober.
The
Teacher, the
last
next
one.
one it's a half into brackets. 1 plus minus cos 10b.
10b. Thank you so much. Thank you so much. So the principle is simple. Are you seeing this angle, this one? We're supposed to double it, as you see. Then this one is supposed to be cos as a must. Then we should have that half in both cases and this one in both cases. Why is this one a plus? Because of cos and cos. Why is this one negative? Because of sine and cos. They are not the same, so minus. Realize today we have done a lot of things. So you really need to sit down and practice them after here. The moment you don't practice, that means you will not notice any change in trigonometry. Many of you have been asking me for this topic, even when I didn't want to cover it, because to me, it was a joke. Like, what have we done since the lesson began? Nothing. We are just copying and pasting things, copying and pasting things. There is nothing much that we are doing. Now, I want someone who knows whatever I taught in lesson 1. I bring you these brain teasers as well. Let me know people are following. Where are those people who followed lesson 1 very well? Have my questions here. The problem some of you just want to wait for the questions. Can't you trust yourself and be like, let me now say I'm ready. In case they are hard, I mute myself. Okay, this is what I mean. I want the answer to that. I want the answer to that. Yes. People, you have refused? People, no one can unmute and speak. People, I want the answer to number 1. Is the answer to number 1 5 or 1? Do you get 5 or 1? The answer to the first one, is it 5 or 1? I think most people had already tried it in the chat and they had suggested the 1. So people, it is a 1. Eh? So in the trigger identities, I remember telling you that they don't mind about this angle. Eh? They don't. But provided this angle is the same. Yes, for you just assume that that angle 5x is theta. So sin²θ plus cos²θ, that is 1. So the whole of this, theta over 2, theta over 2, it's also an angle. Eh? So you just maybe assume it is x. So it is sin² cos²x, which is also what? A 1. Then 1 plus tan, where it is squared. So this angle, you just maintain it on the sec. Eh? Be like sec squared 2x. And these are the things they use in most of the examples. Then this one will be tan, where it is squared of that very angle. The x over 2, you see. Then this one, what is this? Not inverse, I meant squared. This will be cosec squared quarter x. Then this one will be a what? A 1, provided this angle is the same. Problems arise if the angle is not the same. But if angle is the same, then you're good to go. So the rule is simple for those trig identities, same angle. Yeah, provided the angle is the same, we don't mind. The rules stand. Yeah. Think think we've really tried. We've had a lot of rules. Hope people have been following. So trust me, whichever number is going to come your way, it will not be hard at all. Let me try to remind people of something very small. Those of you who attended the first lesson, I want you to solve this for me. Yes. I want to see your answers. But today, people, we have done a lot of proofs. I don't know if you have been following. A lot of proofs have been done. I don't know if people have been following. If you feel that, I'll leave that as research. Then we shall end there. The good thing we still have factor formula, error formula. I'm waiting for your answers on that. I don't know why I forgot that, but it's not hard. I think we need to do it together. You're going to do part B. Let me do part A. So for part A, I will say theta plus 30 degrees is sine inverse of 0.5. Then theta plus 30 degrees. Sine inverse of that one, we said it will be 30 degrees and 100 and what? And 50. So the values of theta plus 30. But remember, so the range I'm taking on here is the range of 0 degrees to 360. Yeah, like that. Then after I get the values of theta, so I subtract by 30, I get 0, and I also get 120. And I also get what? 120. So I think that is obvious. So you people, which are the angles for part B? So you do for me part B, the one that is having negative 0.5. This is theta plus 30 degrees. And this side we have negative 0.5. So when they put radians, you know what to do. So as you do negative, let me also do it, then you just confirm. Actually, this was minus. So let me also put here minus. This was minus. So minus was minus. This is 30. So this will be sine inverse. Ignore the negative. Negative means third and fourth here. So what will you have? We agreed that here it's 210 then 330, isn't it? Then theta will be 240, then 360. I don't know. Do people have those two? Hey. Oh, some people are following. That's good. That's good. That's good. That's good. Okay. 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 This is the assignment. The assignment I'm leaving is related. The assignment I'm leaving is related to the things that were done in the morning. Just because these ones are new techniques. So what if it is cos, but it is 2 theta? Maybe plus 60. This is your 3/2. So D. What if it's your turn and this round it is squared? This is your 4 theta minus 15 degrees. And this one is your 2/2. If it's your sine, this time round it was half theta plus 45. It was your 1. Yeah. So you can give that a try. Hope you know what these ones mean. You take note. Assignment. You're using our normal range. Yeah. Assignment, you're using our normal range. Okay. Now let me see our next stop. So we are going to go through some examples in the book. Then I see what our next stop can perfectly be. So the math syllabus, no, I'm looking for this, I think. So let me show you. We now have some numbers we are supposed to try out. So many. But I just want to show you. Here they used this first identity. You can see, I'm just showing you briefly. So you can see that in this number, hey, they removed the, let me see, where is it? They removed this and they put 1 minus cos. So that was identity 1. I go to the next question, but we shall do them together, don't worry. You can see this question, they removed the cos and then they put 1 minus what? 1 minus sine. We go. But we are supposed to do them together, don't worry. Then what next here? You can see they removed the sec and put this, they removed the cos and put this. You see, those are still identities. This was a proof, those ones are not hard. This was just exercise. They even talked of eliminating theta, which I told you do at once. So this is compound angle formulae. This one we have really tried our level best. We've tried our level best. So those things were done very easy. So these things of evaluating, I think we covered those and we completed. But these were other techniques which we shall see. Those ones are not hard. These ones we are done in the first lesson. Let me see, fine turn. This one has also been done. Double angle. Turn to A. You can see the half angle is also there. can see similarly, they have tried those ones of theta over 2, what we have also. So these were applications. So these are numbers we are supposed to do together. But trust me, as you're going through, you cannot fail to understand. Because they removed cos²θ and they put this, which you know, so you can really follow up. Up to such points, which points I taught you on how to get angles from something like that. And also you can see sin² is negative. And you can also see the angles, which I taught. So I remember telling you that these things are not hard, provided you understand the criteria of how these things come about very well. So this one is proving sin²A, which you guys try to do on your own, and we later did it together. I want you to just follow up. So it came out. You can see they also have this one, of course, cos²A. You see that? These proofs, these ones are easy. These ones you just follow your knowledge. But I told you that they are better when everything has been handled. Like, for example, we are done with all compound angles. We can now do our proofs in peace. We can do them in peace. So you can see the exercise coming in. It's just exercise. Exercise. Then the next thing is about inverse trig. So before you even handle the inverse trig, sorry about that. So I've been telling you that means that our next stop, I just wanted to look at the order that we have. We have inverse trig, but the good thing you're not hearing that for the first time. Inverse trig, they are not hard. I think after inverse trig, let me see what next. After inverse trig, it is now the factor formula. And after the factor formula, I think we shall have the t then r. Let me see, factor formula. This is exercise for factor formula now, the r formula. The harmonic expressions. Then after that one, what next? I think it's solutions of a triangle. Yeah, trig is a very big topic. We're going to see how to handle. Yeah, I think you can see the t formula. Where is it exactly? So after factor formula, then r formula, then t formula. The one I told you for later. So I think after t formula, the last thing is about solutions of a triangle, these ones. Yeah, so for the solutions, these ones, you will find them next holiday. So those who listen to this in the future, maybe the video will be ready. So next holiday, the ones of solutions. So what are we supposed to understand? You realize we have inverse trig, we have factor formula, we have r formula, we have t formula. Oh, serious. That is a bit serious, and I'm a bit worried. So our next stop is first and foremost more examples on application. You just help me one thing and do those numbers I've left. More examples on calculations. You tell people that tomorrow we shall also do mathematics in the morning. You tell them in the group. More examples on calculations. More examples on calculations. Then we are supposed to do inverse. And I think even according to the syllabus, we have inverse somewhere. It's here. Oh, it's here. Are you seeing solve trig involving inverse trig ratios? Serious inverse trig ratios. You tell people even tomorrow morning we have trigonometry. You tell people in the group that doctor said even tomorrow morning we have trigonometry. inverse trig equations. Then after inverse trig equations, we shall have the formula. Then we shall have T formula or T formulae, whatever. Then we shall have R formulae or R formula. The harmonic form. Then I've told you that solutions of the triangle next holiday. That will be the end. We still have a long way to go. Solutions of a triangle, so will be next holiday. But maybe the day scholars, you will have it, maybe. It will depend. So you're going to concentrate on more examples. So everything has been derived in this lesson. So whatever I'm going to be using in more examples, I'll just be using things anyhowly. Then when we reach inverse trig, it's a different story. It is completely different from whatever we shall have covered. More examples on calculations, I meant actually applications. Applications, we have proofs, we have eliminating theta, we have solving for angles. So it is more examples on applications, which I told you about already. So let me hope you have heard what I've said. You should also post that assignment, the second one, to the group so that people can have a look at it. Then I think you can allow me sign out. So I've told you the next stop is more examples on the application, that is solving equations, eliminating theta and proofs. Then we shall have inverse trig equation, factor formula, R formula, T formula. I don't know whether those are 2 to 3 classes remaining, I can't tell. But at least we shall complete those before you go. Then the very last thing of solutions of a triangle, that will be next holiday. That is the last thing. Because we have other things to cover. And that one is not a big deal. But it's a big deal in its own way. But we shall handle that last. Because it will be the last subtopic to conclude with trigonometry. Yeah. So I think you help me post those. You help me post those what? Help me post the assignments I've left today for people. Then in the morning, at least you come, we do more examples and maybe also do inverse trig. So that we understand that we are remaining with only 3 things. Factor. I don't know, tomorrow let's do factor formula. So when we do factor formula, we shall solve at once. Someone may be like, why haven't we solved at once? No, I want to solve when we have done factor formula and its reverse. So we're going to do factor formula first and its reversal. Are you listening? Then we do more examples at once. Yes, think it will be better. Then, as we do more examples involving solving, we shall also do the ones of inverse trig. Because most of the things have been talked about today, so I will need a lot of explanation in that lesson. Because even factor formula is very easy. So that means we shall be left with, tomorrow morning session, we shall be left with, let me see, T formula, R formula, T formula and R formula, isn't it? You people, if we do factor first, we do more examples, then inverse trig. That means we shall be left with T and R formula. T and R formula. T and R formula can be combined in the same session. So 2 to 3 sessions we shall be done with what I want. So that's the simple plan. So make sure tomorrow you try to keep time. We do those 2 things as planned. Yeah, so you tell people in the group that tomorrow morning it is still pure math. Yeah. Strictly trigonometry. So that we be remaining with R and T. But trust me, if you forget any of what we have discussed today, it will be very absurd. So those who have copied notes, please make sure you review everything. That's my number for WhatsApp calls. Yes. So Paul Tutor Science Math Tutor at Science Scholars Academy based in Uganda. I'm one of the members. I always tell you that the students who are organized, I will tell you in the future where to access our work from the app. Just go and download it and access the work for free. In the future, yeah, the future can be next month. Otherwise, thank you for listening. I've been seeing people saying something in the chat. I don't know what it was exactly. I don't know what it was. I don't know what it has been exactly. Maybe I can check. I can check, then I leave. Okay, I don't see anything serious in the chat. So, for those who know trigonometry, have it in mind there are your friends who have not covered this topic. So it's actually me teaching them. There are some of you who think we are revising. We are not revising. I'm covering it as a real topic. So if for you think trigonometry is okay with you, go to the drive and study DEs. Differential equations are there. Go and study complex numbers. They are there. You go and complete normal distribution. There are so many topics there, especially in pure math. You go and complete them. Lessons of integration, there are 9. But for trigonometry, I will teach it from scratch. So you'll have to give your friends time or just learning it. There are those who completed it but never got a thing. So we are supposed to go with a pace that will favor us all. Yes, no need to panic. We have a full year to make results. So just trust the process, like I always tell you. Otherwise, just because you people, you're tired. The moment I saw people reducing, I got to know that people are tired. But for me today, I'm not tired. But I already just want enough math students so that we calculate some good numbers when people are on. But I know the number was very... you people, you're saying mechanics. You people, you be serious. We completed projectile, we completed forces. That means mechanics, we only remaining with only 3. That is friction and Newton's laws. That is motion of connected particles and relative motion. You people, and we have a math. Even if I just choose one, maybe I choose relative motion or any of the other 2, then next Friday we cover 2. The problem is people don't trust the process. I don't know why. No, someone saying NRM. Yes, I know, but I told you cannot teach NRM without root location, and you cannot start the root location without linear interpolation. But we finish interpolation and extrapolation, so we are supposed to cover root location first. So whoever will be listening to this in the future, those lessons will be there already. It is these current people who are complaining and not trusting me. So those who are not tired, you go to the drive. Yes, you go to the drive. You go to the drive and maybe do something. But remember, we are supposed to do calculations next, so people should be online. I do one, you do one. I do one, you do one. So even in the morning, we shall do that. The good thing, even the biology students, most of them do math. So it is okay to use part of the biology day for part of what. Anyway, I will see from there. You people, bye. Thanks for attending. You're loved.